And you're going to have a bunch of equations that you're going to have to graph. And we are going to use one of two methods depending on the situation. Okay? The first situations are for the non-linear graphs. The graphs that are not straight lines. Let me remind you which ones those are, because I'm expecting you to know which ones are nonlinear. I'm hoping you know the quadratics are nonlinear, that the absolute value functions are nonlinear, the exponential, and I'm expecting you to know that piecewise are not linear as well. Piecewise functions. And I'm going to give you examples of what those look like. Quadratics are these parabola-shaped graphs. Exponential are graphs that get exponentially bigger or exponentially smaller, usually. Absolute value functions are the ones that are V-shaped. And piecewise functions are the ones that you have two pieces and you put them together and it makes a graph of two pieces of two different functions. If you are given a quadratic equation, this is the method that you're going to use to graph it. This first method I'm going to show you. If you're given an exponential or anything like this, you're going to use this method, and it's called making a table. When you make a table, the hardest part is picking the numbers. I'll give you an example. Here is an equation. Y equals the absolute value of x minus 2 plus 3. The hardest part about making a table is picking what point is going to be your center point. I'm going to write off to the side. Center point. Because I'm going to talk with you about how to find the center point in just a second. But what I want you to do is I want you to make an x and a y, and then I want you to have room for 5 numbers. 1, 2, 3, 4, 5 lines on my piece of paper. I have an x, a y, and then I have 5 different lines that I could use here when I make this chart. This is an absolute value function. It should make a V-shaped. But the hardest part is figuring out what is your center point, or the bottom or the top of this absolute value function. And so I'm going to write something down here. I want you to write it down as well. It says the center point is the opposite number of whatever is happening, quote unquote, inside the function. My center point is the opposite number of whatever is happening inside the function. In this example that I have here, the function is the absolute value function because I have these absolute value bars right there. And so if I'm looking at this 3 is outside of the absolute value function. I can ignore it. I can ignore the 3 because it's not inside the function. What is inside the absolute value bars is this x minus 2. I want to do the opposite number of whatever's happening inside the function. See how this is minus 2? What's the opposite of minus 2? that is your center number for your x. That's the way I recommend you figuring out what your center number is. And then you're going to need numbers that are bigger than that. Give me a number bigger than 2. I appreciate anybody who said 3 because that is the next easiest number to use. The next easiest number to use after 3 is
4.
So I want 2 on this side of the bottom of the V, and I want 2 numbers on the other side. This is why it's called the center point. So I need to go before 2. What is before 2?
1.
And before that?
0.
So we have 0, 1, 2, 3, and 4. Those are the points that we are going to plug into this table. What that means is we're going to do this now. We're going to plug in y equals the absolute value of blank minus 2 plus 3. Instead of x, we're going to plug in 0 in for x. And you're going to figure out what that is. If you don't know what that is and you are a calculator person, there is absolute values on our calculators, and I want to show you where it is. This ABS button that I'm pointing to right there, ABS does not stand for abdominals. It actually stands for absolute value. So if I press Shift, abs, what shows up on my calculator is this, which is kind of nice because then I could do 0 minus 2 and then outside plus 3. What it's doing is it's saying 0 take away 2 is negative 2, and the absolute value of negative 2 is a positive 2. Positive 2 plus 3 is 5. That's what y is when x is 0. And then what we have to do is the same thing for the next function. Do you want me to use the calculator again? Or do you want to do it in your head? It's not 6. And I want to make sure you understand something. We can do this one in our head. 2 minus 2 plus 3. Do not assume that this is going to follow a pattern. Don't go 5, 4, 3. Oh, I know what the next one's going to be, Miss Problem. Nope. Don't assume that, because this is your center number. What we are doing with our center number is this. We are finding points, and we are now to the center number, so something should happen when we go to the next point. The next point should go in a different direction. Let me prove it to you. 3 minus 2 plus 3. What's 3 minus 2?
4.
Plus 3 is? So the pattern changes because it's not a linear function. It's an absolute value function. And maybe you know what goes here. Good. And now you have a table of values that you can graph. So what I recommend you do then is to draw your x and y, just like I'm doing right there. And since your x's are going from 0 to 4, I'm going to write 1, 2, 3, 4, and I'm going to write those numbers down on my x-axis. I'm even going to put 0 there just so I know where it is. What's the biggest y I have to go to? So I'm going to count up to at least 5. 1, 2, 3, 4, 5, and then I'm going to number them as well. And then all I have to do is plot my points. And if I do it right, it should resemble the thing that I know it should be from unit 0. This should be an absolute value V-shaped graph. 0, 5. The x is 0. The x is 0. The y is 5. I go up to 5. 0, 5 is this place right there. 1, 4. The x is 1. The y is 4. Now here's my center point. 2, 3. I'm expecting my center point for something to happen before it and something to happen after it. 3, 4. So I'm just going to draw a little arrow here. This is my center point right there. And this is my center point right there. On the graph it does something different. On the table it does something different, and so on. If you do it right, what should this shape be? A V-shaped graph. This is a V-shaped graph, and this is how we graph this particular equation. Does that make sense to you? Piece of cake. Let me show you one more example. I'm going to start you with it, and then you're going to try making your own table. Here's the example. Y equals negative 2x squared. Let me go up a little bit here, recenter this for you. And I'm going to put an x and a y here. I'm going to count 5 spots. And I'm going to make sure real quick you know how to find the center point, because the center point is the hardest part about this graph. Do you know which type of function this is up here of your 4 choices? Which one is this?
Quadratic.
It is a quadratic. And so what's inside a quadratic, why is something a quadratic? Is if it's something squared. The thing inside the quadratic, the thing inside the power of 2 is the x. This 2, this power of 2 does not touch that negative 2. It's outside of the function. This is a quadratic. This is what's outside the quadratic. Now this is the hard part. The center point is the opposite number of whatever is happening inside the function. Now here's what's inside the function. I'm covering up everything except for x. What is happening to that x? Over here, what was happening to the x? It was minus 2. We changed that to a plus 2. What's happening here? What's going to be our center point? Tell the person you're sitting next to what you think it is. I don't hear the right answer yet. Still don't hear the right answer. Okay, wait. Let me do it this way. Re-explain. Re-explain. What's inside the function? What's happening to the x? We subtracted 2. We are going to do the opposite of subtracting 2. We're going to add 2. Now we go back here. What is being added or subtracted to the x?
2.
No, because that's outside the function. 0. Somebody said 0. Thank you. 0. We are adding. Okay, wait. Let's explain it this way. We are adding nothing to the x. We are subtracting nothing from the x. So if we're adding or subtracting nothing, there's a number that represents nothing, and that number is 0. It's how much money's in my pocket right now? 0. It represents how much money's in my pocket. Okay? This is your center number. So then what do? I want a number that is bigger. 1. And 2. Thank you, Dora. I also want a number that is smaller. So what am I going to use? And? Okay. I'm going to turn off the recording. I want you to see if you can do the rest of this and graph it on your own. And then I'll record once I give you time. Okay?